Hi everyone, I'm Josemary on behalf of GenScript, and today we are interviewing NCSU iGEM. So NCSU iGEM, can you please tell us more about your project and how you're getting ready for iGEM 2023?
It's really nice to meet you. My name is Neha. I'm the wet lab brief lead for the Bloom NCSU this year, and Ram is the dry lab lead. We're graduate students at NC State University, and we've been working on this project for around a year and a half now. So we're excited to take it to the iGEM 2023 cycle and present it at the Jamboree this year. Uh, I mean, I'll, I think Ram is just getting himself set up. I'll quickly start presenting the slides, and he'll introduce himself. Can you guys see my screen?
Yes.
Thank you. So we are a first-time team from NC State University. There has been one PhD team that has gone before us. We are a team that consists of both graduate students as well as undergrads. And we have a 50-50 ratio. So our project is called Forget Me Not this year. We intend to go after Alzheimer's disease when there is a root cause to the disease before there is steep cognitive decline that is like visible on the person. We live in a world with an increasingly aging population. So we're trying to find out the MCI stage of the Alzheimer's disease. We're trying to diagnose it then. MCI stands for mild cognitive impairment. Ram's team uses a quantum machine learning model. Quantum computing is a resource that was uniquely available to us on NC State's campus. Therefore, we leveraged it, and his team created a quantum machine learning model that took in a large data set of MRIs and then classified them into MCI, that is mild cognitive impairment, cognitively normal, and Alzheimer's disease. So we are, with this model, we are trying to find the fault line between MCI and AD. So once he is in a position to diagnose when this MCI stage is for a particular patient, we come in. The wet lab is trying to make a Clostridium-based therapeutic, preemptive prophylactic therapeutic for Alzheimer's disease by increasing the butyrate that goes through the gut-brain axis. And by releasing this SCFA, this short chain fatty acid, we're in a position to bring down neuroinflammation as well as protect neurons that are currently happening. So our take on this is that Alzheimer's is not an unstoppable force. The FDA approved drugs that are currently on the market are pretty expensive, and they only can slow cognitive decline to a certain extent after the disease progresses beyond Alzheimer's disease. Therefore, we are trying to hit the root cause of the disease at a point when some damage control can be done rather than when it is too late. So we're trying to, so the wet lab is going after Alzheimer's disease, and it is characterized by the progressive loss of neurons and the accumulation of abnormal amyloid beta plaque depositions in our brain. The dry lab is trying to figure out when this diagnosis should take place and what cognitive impairments are evident, and before cognitive impairments are evident. And in human practices, we started surveying stakeholders. Once we decided that dementia is what we wanted to go after for our particular project, we started looking at stakeholders of Alzheimer's disease, basically the doctors, patients, as well as caregivers of Alzheimer's disease, in order to create a proper integrated human practices effort for them. So we decided to create an app. This app is, this caregiver resource app integrates medical records across the spectrum of the patient's care. For example, for the dementia patient, remember them, who they were and what they were doing. We have kind of made a PDF of sorts where they can document their journal, their daily habits, their day-to-day activities, and this is integrated on an app that keeps their medical records together. So if they tap an NFC card, the doctor gets their medical information in a HIPAA compliant manner, and as well as we'll be in a position to gauge the daily habits of this person and help them out as necessary. We are also authoring a neuroethical report, which does a deep dive into the ethics of every aspect of our project, patient data privacy, and how we need to safeguard it. And yeah, these are the three aspects of our project. We also had the privilege of speaking to the University of Nottingham 2020 iGEM team, and they had a pretty similar project to ours. They were using Clostridium sporogenesis and they use the spores to create a preemptive therapeutic for Parkinson's. We're using Clostridium butyricum to create a preemptive therapeutic for Alzheimer's disease. The only difference being the chassis organism and the fact that this chassis organism was selected after like extensive literature review of the recent past, and the fact that Clostridium butyricum has proven time and time again that it is a good supplement in vascular dementia. This non-model organism, we're trying to get more information and create paths that will help other teams beyond us. So we are currently looking for mentorship in these particular areas. We were looking for peer review of our neuroethical report and like the optimization of our paths. So we've been coming up to industry professionals like you and attending, conferences like SynBioBeta. We've been trying to design biosafety in the gut because we are dealing with the enteric nervous system and we're trying not to colonize the gut. And marketing and business model for such a probiotic and what FDA regulation will be required. These are the three areas that we're looking at this stage of the competition. For impact, this is actually something that we've taken from the Nottingham's project. We have their permission and we've been trying to figure out a similar mode of implementation in the form of a capsule. They use the spores of Clostridium sporogenesis, but we are trying to make a probiotic version of that with Clostridium butyricum. We're still in early stages of ideation as far as delivery and delivery goes. But yeah, this project serves as a huge inspiration on our end. And yeah, our neuroethical report is almost complete. We have been asking for peer reviews from all our colleagues and iGEM teams who are working on similar gut-brain axis or like neurodegenerative diseases. It's almost a 24-page report, and we go into the general CRISPR gene editing and its ethics, as well as our particular experiments and what we had to keep in mind and what we did to the best of our ability to remain integral to the science. Yeah, so our Instagram has a gut microbiome library series. This is an education initiative that we are having with the high schoolers in the local North Carolina region. They read up about the different gut microbiomes and the different organisms that live in our gut and how they can contribute to both health and disease. And they create these cute little posts that we actually put on our Instagram. And we're aggregating those as a gut microbiome library on our Instagram. We also have an education for high school students for the Genes in Space competition. We're going after the education prize. So this is our timeline for this competition cycle. We intend on sticking to it as much as we can. And yeah, the team, our PI currently is Dr. Eric Rottenberg. He's the dry lab PI and he's working with RAM on quantum machine learning. This is our wonderful team. We really wish they could have made it today, but I think everyone was in classes. We are currently having summer classes. And yeah, our current collaborations are with these three universities. iGEM Trace is helping us with the neuroethical report, helping us with the gut-brain axis. iGEM Macula is creating a biome book, which will take all the posts that we're making on Instagram and aggregating it. And the two universities in the Research Triangle Park, that is NC State, Duke, and UNC iGEM, will be coming together for a mini jamboree at the end of this year. So this is what we're doing. I'll be happy to take questions. Thank you.
Thank you so much, Neha, for presenting that on behalf of your team. So you mentioned at the beginning of your presentation that your team is using quantum modeling to look at these systems and quantify the different ways that you can use the biotherapeutics. Right. So can you tell us more about the systems that you've integrated into that quantum model?
Sure, that is Ram's area of expertise, but we're trying to make it a diagnostic model and not something that gauges how much of the therapeutic we give. We are using normal machine learning for that. He's trying to figure out at what stage or in the disease, how and when to give it. I'll let him take over. Sorry.
Yeah. I'm Ram. So like about myself, so I'm a computer engineering graduate from NC State. So I'm currently leading the dry lab team for the iGEM 2023 competition. So we are primarily have working on like using quantum computing and machine learning techniques. We are combining both of them to provide um, a solution for this Alzheimer's disease. So we have a structural MRI, and from there we will directly pass the MRI to the model, and this combined model, like the machine learning model, along with the quantum computing, quantum mechanics along implemented in it, we call it like a quantum machine learning model. So along with this model, we were able to predict at which stage the patient is currently in. So we train the model using like previous data from other patients. So we have like an MRI which is being trained for like MCI or cognitive normal or Alzheimer's disease. But once after that, the training is done, we currently can upload the present person's MRI, and then get the classification result. So this is like an early detection.
I see, and thank you for explaining that further. And then for you mentioned that you would like to use Clostridium butyricum as a model organism. So, can you tell us more about how you went about examining and selecting your model organism for potential biotherapeutics?
So how we went about selecting it is it was mostly conversations that we had with the iGEM team I mentioned, the Nottingham team. They had decided they were going to use Clostridium, which is usually pretty finicky to edit. So we asked them why they chose that and how effective it was. And they seem to have a lot of promising results. So we started doing a deep dive into the literature. The literature review proved that we had a couple of chassis organisms. We had Lactobacillus buchneri, we had Bifidobacterium, we had two strains of Bifidobacterium and Clostridium sporogenesis. We could work on what they did and maybe have it adapted for more butyrate production in Alzheimer's, or we could have used Clostridium butyricum. Recent literature from 2015 to 2023, there was a very recent paper less than a month ago that highlighted that Clostridium butyricum as a prebiotic had been very beneficial in dementia. So we decided that Clostridium butyricum should be the way to go for this particular competition cycle. We have been trying to, since it's a non-model organism, we're trying to get as much genomic information about it before we actually go to the lab. But yeah, that's where we're at, right?
Lastly, I also have a question about your app. So I think your app is a very unique approach to your human practices, and it definitely integrates the community uh, in a very active way and in a way that supports your research. Could you tell us more about the impact of what gathering that type of data might do to help support some of your findings for your project?
Sure. So I think one of the main ways it supported our findings for our project was the fact that we were in a position to gauge. Um, h- so during the pandemic, when we spoke to stakeholders, it had said that there was a lot of research and resources had like come to a moot point during the pandemic because the biotechnology industry was focusing on different things at that point. So they had there was a period of decline in this research and in this development during that time. So when you were trying to create this app for caregivers, we were trying to ensure maximum data privacy to make sure that we were HIPAA compliant even at a prototype stage. And the usually the feedback we got was customer feedback on whether they liked this interface, whether it helped them streamline, whether the caregivers were in a position to streamline their day-to-day activities, whether they had more time to take care of the patient rather than administrative tasks on a general basis. So that's the kind of information we got from them, and that is the kind of information we took their permission, and it's laid out in the neuroethical report. So our journey of coming to this app and then of actually taking the data from this app to create the rest of our project, we've laid out on this neuroethical report. But I think our project fed more into the app than the app fed into the project, because it was we started out with this and then we landed on the app rather than the other way around.
Well, thank you so much, NCSU iGEM, for meeting with us to tell us more about your project. On behalf of GenScript, we wish you the best of luck in the iGEM Jamboree and in our iGEM sponsorship competition. Thank you so
Thank you
much.
so much.